Question number 3 asks me to match each graph with the correct slope of the line. So to do this, I need to be able to understand that the slope is actually the rise over the run. The rise over the run. That's the difference in my y values over the difference in my x values. Now in this case, this is a drag and drop problem. We're going to see a lot of these on the newer STAR test. This is a new STAR question type. We're expecting to see many of these, and this might be the type of question we see on the STAR. You will certainly see it on your test in exactly this form, and this review then gives you a question that's similar. So remember, rise over run. That's what the slope of my line is. I'll start at the lower of the points. So let's look at this first graph, and I'll rise 2, and then I will run 6. Up in the positive direction 2, sideways to the right in the positive direction 6. So that is a positive 2 over a positive 6. If I put this into Desmos, it'll reduce it for me to 1/3. I look down in my answer choices. Do I have a 1/3? I do, in fact. And I will go ahead and I will insert that there. Now, erase that. Let's take a look at the second graph. I rise 3 and run 3 as well. Positive 3 over a positive 3 reduces to a 1 when I put it in Desmos. Do I have a 1? I do. I plug that value in as well. For my final graph, I'm going to do something very, very similar. I'm going to start at my lower point. I will rise 2 in the positive direction and run 4 in the positive direction. That means I have a 2 over a 4. 2 over 4 reduces to 1 over 2. I look down, I see a 1 over 2, and I will plug that in. How does that look when I go to the edge elastic? It looks a little something like this. So we'll switch over to edge elastic. I go over to my drag and drop values. I'm going to click on them, and I'm going to drag each slope into its appropriate drag and drop box. Now, it's important to remember here, I'm not going to use every possible value in the drag and drop boxes. I'm only going to use some of them. When I'm clicking and dragging, notice that when I get the item within the box lights up blue, and that's when I can release it and drop it into the box. So if you're having trouble with that, everybody's computer sensitivities are a little different. Just make sure that it's highlighting in blue. Let's move on to question number 4. When we go to question 4, notice this is a little bit different question type than what we had before. This is the graph of a function, and we're being asked in this particular problem what the domain of this function is. We're going to have a lot of these type of review questions throughout the year, so it's important that you remember these concepts and be able to perform them all throughout the year. Now, my domain is my x values. So as soon as I see domain, I'm thinking every possible value of x. Those are my side-to-side horizontal values. On graphs of this sort, where I have a closed point and then an arrow on the other side, it's important that I start with that closed point and draw a line at that point to figure out, at the closed point, what is the value of x? Well, when I look at this, the value of x at just that closed point is a -4. Now, that's not my domain. I have more values of x. Notice that's a continuous line. So every value of x on that line, going for an infinite amount in the right direction, in the positive direction, will be part of my domain. I would express that x is greater than or equal to a -4 in the following manner. X is greater than or equal to a -4. Equal to because of that closed point. And now I need to look at my answers. Do I see an answer choice that is x is greater than or equal to a -4? I do. In this case, it's going to be answer choice A. So I would switch over to my edge elastic. When I switch over to the edge elastic, I'd look down, I'd click on option A. I'm good to go. I can head to the next question. Question 5 on the review asks me to match the given slope, which is an m value, and y-intercept, which is a b value, with the equation of the line in slope-intercept form. What I need to understand here is that my slope-intercept form is y is equal to mx plus b. In this question, my m value is a 2, and my b value is going to be a 5, at least on the very first option. So I need to substitute 2 for the value of m. I write my x, and then 5 for the value of b, plus 5. So the equation that I would write here is y is equal to 2x plus 5. Remember that the slope is the number in front of the x, not the x. The x is not part of the slope. The slope is the coefficient of x. And there is my answer. I would click and drag that up into the upper box. I'm going to do the other two fairly quickly here. Y is equal to my m value, 3x, plus my b value, 5. Do I see 3x plus 5? I do. I draw that, and I take it and put it into the box above. Last one, y is equal to 5x. My slope is 5, plus my b value, which is 4. I see that as an option choice as well. I'll bring that up and drag it into that box. Let's see how this looks in the context of the edge elastic. Again, this is just a drag and drop. I take my equivalent equations and I will drag them from the drag and drop box. I will place them in as soon as they are highlighted in blue. I know I can drop them there, and I'll do that for each one.